Hi folks, welcome back to Physics with Captain Rod. I'm making this video here to discuss with you the concept of potential energy. So we're going to start with this. We've got young Timmy here at the top of this building. And imagine that Timmy takes that rock and somehow that rock ends up here. And don't worry about the house, just it does. And we're going to talk about three different possible paths here. Path 1, path 2, and then path 3. And we're going to kind of investigate the work done by gravity for each path. So looks like we're going to start with path 2 here in my notes here, the blue one. So the work done by gravity as we go from here to here would be positive mgh, h being the height here that the rock has moved. And that would be positive during the first part, or during that motion, because the gravitational force is down and the displacement is down. For the second part here, the work done would be 0. At least the work done by the gravitational force, because the gravitational force is down, but the displacement is to the right. They make a right angle. So the net work is mgh, positive. Now if you take a look at path 1 here in green, the first part of path 1, the work is 0 because of the right angle, and the second part is mgh, positive, because the gravitational force is down and the displacement is down, and again we get this term, positive mgh. All right, the third path is this linear kind of straight line path, and maybe I'll draw a little more of a picture here. So here's the rock, and the gravitational force is down equal to mg, and there's some sort of angle here. So if we calculate the work done by gravity as the rock goes from here to here, it would be mg cosine theta times this distance. Now the cosine theta is giving the component of the gravitational force that's in this direction. Now it's not too hard to show that cosine theta, right, this is theta right here, and cosine theta is equal to h over d. So it's not too hard to show. You end up with positive mgh again. Turns out that no matter what path you take, as long as the rock starts here, ends here, you're going to get mgh. And it's actually a little bit broader than that. It turns out that as long as the rock starts anywhere at this height, ends up anywhere at this height, you're going to get mgh for the work done by gravity. Because we know the work done based on these locations, what we can do is we can basically call this a potential energy, right? Really mathematically what we're doing is we are defining a potential energy for the gravitational force. We can do this because the gravitational force is a conservative force, and one of the properties of a conservative force here is that the work done between two locations is not dependent on path. We actually can do any path we want, and you're going to get this term mgh. So we're going to define potential energy. Potential energy is energy due to position. Effectively, a potential energy term, got to work on my spelling there, but effectively a potential energy term is a work term, and it's the work done by a conservative force as the object moves to different locations within the system. So I hope that this video, backing up here, and for the gravitational force, where g is uniform and constant, the potential energy associated with it is mgh, where h is the height measured from a line called the datum. Now, the datum is a position that you define the potential energy to be 0. And we'll talk about why you can do that mathematically later on. So this is a concept you should be familiar with from physics. The lowest point in the diagram is typically a good place to put a datum. So in this example with Timmy, if we put the datum here, then we would say, all right, this rock has a positive potential energy equal to mgh. We could also put the datum here and say that the rock is starting with a potential energy of 0, ending up with a potential energy of minus mgh when it gets to the ground.
and there are an infinite number of other variations we can do. So I think I'm going to leave that video or end that right there. I hope that this helps you understand a little bit about what potential energy is. Have a great day.